Hi. We've developed an algorithm to find the perimeter of any shape. But are we ready to turn this algorithm into code? Well, we could, but we'd like to be confident that it's right before we do that. After all, there were a lot we had to do to generalize our steps, and it's entirely possible that we made a mistake. Or perhaps we just didn't think through all the special cases. So before we turn this into code, we should test it out. To test the algorithm, we need a different instance of the problem, something other than what we used to make the algorithm. In fact, it's good if our test instance is pretty different from the one we used to make the algorithm. Here, we've shown a triangle instead of the four-sided trapezoid we used when we developed the algorithm. Before we go any further, take a second to figure out what the right answer is. What is the perimeter of this shape? When we finish, you'll want to check if the answer to our simulated algorithm is correct. And to do that, you'll need to know the right answer. Now, we'll execute the algorithm by hand for this particular input. As we test the algorithm, notice the similarities between the code and English. We're going to execute this English algorithm by hand, just as we executed code by hand. They both work pretty much the same way. And that's not a coincidence. When you turn this algorithm into code, you want to write down code that has the same semantics as the English, the same meaning. The code should transform the program state in the same way that the English transforms this diagram. So we'll start with total perim and set it to 0, and prev point being the last point in the shape. But what is the last point? We'll say the points in this shape start at the top and go counterclockwise. So this point in the lower right-hand corner is the last one. And we'll initialize prev point to be that point. We'll note briefly that if this were actual Java objects, prev point might be an arrow pointing at an object. But we're going to just write down the coordinates here to keep the diagram simple and legible. Next, we're going to do the steps for each point. So we need to start at the first point, which is this one at the top of the diagram. And that will be the initial value of cur point as we enter the for each repetition. Then we'll find the distance between these 2 points, which is 10. And we'll update total perim to be 10, 0 plus 10. And then we'll update prev point to be cur point. Now we're at the end of our for each repetition. So we'll update cur point to be the next point in the shape, which is -3, -4. When we update cur point, we go back to repeat these steps. We repeat the steps again, finding the distance between those 2 points, which is 8. And then we update total perimeter to be 10 plus 8, or 18. And then we update prev point to be the current point. Then we go back to the top of our loop, updating cur point. We repeat these steps for the last point in our shape, after which we've gone through all the points. So we skip to the steps after our repetition. Here, we can say that total perim is our answer. Total perim is 24. Is that the answer you came up with earlier? Yes, that is the perimeter of this shape. The fact that our algorithm came up with the right answer here gives us more confidence that we generalized correctly. We're done executing the algorithm by hand, and we have some great confidence that it's correct. So we're ready to turn the algorithm into code.